So all I want to do in this particular podcast is play around with your calculator and see what kind of values we can get hitting the log key. Yeah, okay. So on your calculator, you have a log key. It's usually right there, especially if you're dealing with a Texas Instruments style calculator. Okay, so let's boot this up. Let's boot up our calculator and let's just use what we got, right? Okay. So I have my beautiful calculator sitting right here. Let's go to town. First question is, of course, log of 10. So I'm going to hit the button here, log, and it's going to give you the common base, because if you look at every one of these logs, take a look at these. Every one of these logs, the base is not written. So because we're dealing with the common logarithm, you always expect this to be written as log base 10 of 10. Ah, I see now. I understand there. So instead of writing out log base 10, you just assume it to be 10. Okay? So all of these are base 10s, which is going to bring us to our nice common logarithm, which is that guy right there. Okay? Ready? Here we go. Boot up the calculator. So I'm going to go log of 10. Okay. If you want to close the bracket, go ahead and close the bracket. Punch it. Watch it. Look at that. I get 1. Oh, interesting. Okay, well, what's the log of 100 then? Log of 100. Huh. Okay, I wonder what that is. Oh my God, yeah, it's 2. Do you see a pattern yet? What do you think the log of 1,000 is going to be? 1, 2, 3 zeros. Okay, hit enter. It's 3. Oh my God, yeah. That's just too cool, because then if you think about it, the log base 10 of 10, think of that word, base 10 of 10 is 1. Wait a second. Didn't we say earlier that we can have a log base 10 of 10 equals to x? But wait a second. Isn't x equal right now to 1? And didn't I take this base and say, take the base and raise it? What is 10 to the power of 1 going to give you? It gives you 10. It gives you this number. Oh, I'm beginning to see the relationship. I don't know about you. Oh, my goodness. Look at this one. If this was a log base 10, right? And we got an answer here of 2. Okay, so log of 100, base 10, we said the answer is 2. 10 to the power, oh my goodness, 10 to the power of 2. Is this 100? I see a relationship. Look again. Look at this guy. This was log base 10 of 1,000. We said that equal to 3. Watch. 10 to the power of 3 is your original question, which is 1,000. Isn't that interesting? Do you see the relationship now? This just makes so much sense. Okay, with that in mind, let's get rid of all of this stuff and let's go and see if we can start doing this in our head then. Okay, 10 to the power of what gives me 10? 1. 10, which is the base of 10, to the power of what gives me 100? 2. 10 to the base 10, there's the base 10, 10 to the power of what gives me 1,000? 3. Uh-oh, what do we do with this? Well, if you think about that, that's the 10th position, that's the 100th position, isn't it? So the 10th position, the 100th position, this is like 1 over 100. Well, I know that 100 is 2, isn't it? But don't forget, this isn't just 2, this is now flipped. That's a flipped version of this. So I bet you that's going to give me an answer of -2. Let's bring up our calculator and let's see. The log of 0.01, right, is, let's see. Oh my goodness, it is -2. So think about it this way. There's the tenths, there's the hundredths, there's the thousandths, there's the 10,000ths. So this is 1 over 10,000, which if you think about it, is the same thing as saying 10,000 to the -1, to the power of -1. And 10,000 is 1, 2, 3, 4 zeros. This is 10 to the power of 4 to the negative 1. So it's got to be 10 to the power of negative 4. I bet you this is negative 4. I bet you it's negative 4. Let's try. Let's bring up our calculator again, and let's see if that actually works. Here we go. Ready? Log of 0.0001, right? 3 zeros and a 1. Bracket, is it going to be negative 4? It is. So cool. Incredibly cool. Now, down here it says try rewriting these as a power, and that's what we did already with this section. But let's see if we can do this to this section. Remember, this is log base 10 to the power of negative 2, which you know is 1 over 100, which is, as decimal, that. This would be, of course, log base 10 to the power of negative 4, which is, guess what, 1/10,000th, which is that number there. Is that not cool? That is just so incredibly cool. Okay, so a logarithm of a number is the exponent of 10 that produces that number then. Oh, okay. So the log key gives the exponent for a power of 10. That's all it means. Huh. Well, let's keep on going. Let's have some more fun then. Then you know that by definition then, 10 to the power of y gives us x. 10 to the power of y gives us the x value. So conversely, 10 to the y equals x is equivalent to log base 10. Because there's the base, there's the base. Got it? Got it. So let's keep on going. All right. So check this out. This is going to freak you out here. Watch. Watch. Log base 10 of 5 then means 10, if it's equal to y, 10 to the y, right? 10 to the y has to equal to 5. Ah, I see. So that means whatever this number is, you know what? Let's find out that number. Let's go out and actually do this in our calculator and find out what log base 10 of 5 is. Now, obviously, 5 is not a pretty number because, of course, if you're looking at a base of 10, 10 to the power of what gives me 5? I have no idea. So let's bring up the calculator and let's figure out what it is. Let's clear all this stuff out of here. And let's go log, which is a common log, so it's automatically base of 10, of 5 gives us, what a horrible number. 0.698970004. Oh my goodness, that's gross. But my question is that according to this, if this gives you 0.698, 0.698, shouldn't we be able to say 10 to the power of 0.698? I better get 5 back, shouldn't I? Because 10 to the power of 0.698 and all those crazy decimals there better give us this value of 5 back. Well, how do I do that? Well, what's really cool is if you look at your calculator, you're talking in inverse. And look at this. There's the log, but right here is 10 to the power of x, the inverse of log base 10. Oh my goodness. Let's see if I can make this work. So let's take this 10 to the power of what the answer was, this answer. Let's see if we get 5 back. Let's play. Okay? So how do I get to it? Well, of course, second log, there's 10 to the power of, and I want this number here. I want this 0.69. I want the whole thing out there. So I'm not going to go out and copy this. I'm just going to mouse up, and I'm just going to hit enter. And there it is there, that whole ugly number, and hit enter, and check this out. I get 5. Goes to prove that even your calculator does the inverses for you quite nicely. Oh, this is fun. Okay, so let's keep on going. Let's finish this podcast off here with a couple of interesting numbers. Let's go and do the log base 12. Or actually, log base 10 of 12. Okay, let's bring up the calculator. Here we go. Clear this out of here. Log of 12 gives me this crazy number, 1.079. So that means if I take the inverse of the log, that of this number, right, I should get 12 back. Well, okay. I do. Look at that, hey? Isn't that just incredible? So this is one, your answer is 1 point, what was it? 1.079. Okay, 1.079. But if I did the opposite and did 10 to the power of this, it gives me 12 back. Let's do the same thing for log 63 and see if that works. Okay, here we go. Ready? Log 63. Log 63. Boom. Enter. 1.799. Okay, so I should be able to go and do the inverse. The inverse of this number right there better give me 63 back. 62.9999. Again, your calculator's not perfect. It rounded it off. 62.999999 is 63. Cool. Okay, so let's have some more fun. What if the base is not written? It's assumed, of course, to be a base of 10, common logarithms. So let's look at all of these common logarithms here. Let's do the log of 0.6. This should be interesting. Notice that gives you a negative number. Why is it a negative number? Because remember what 0.6 was. 0.6 was 6/10. It's now a fraction. Fractions end up becoming negative numbers. Oh, cool. Let's do the log of 0. Okay, let's see what that is. I'm kind of curious as to what the log of 0 could possibly be. The log of 0. Here we go. What? I've got an error. Remember the graph? Remember the graphs of logs start here and then go this way? So in other words, non-permissible value. That's not allowed, right? And if you think about it, anything less than this asymptote is not allowed either. So I can predict the answer to that one right now. I bet you this one is no. And I bet you this is even a bigger no. Oh my goodness, let's see. Log of -5. Let's see if that works. Okay, so we're going to have to clear this. Let's go log of -5. And let's go and see what that works out to be. That also gives you non-real answers. So you can't have a log of a negative. Oh, that just goes and proves all the stuff that we did graphically. So log of 0 and log of any negative number does not exist. Remember, this shape of the graph is going to help you understand an awful lot of that calculator stuff we just did.